The cosmos is always reaching out to us, yet more often than not, we fail to notice its call. Its messages come in the form of light, gravity, and the faintest traces of radiation journeying across unimaginable distances. Our own solar system feels peaceful until the universe decides to surprise us. On this day, September 5th, 2025, we find ourselves witnessing one of those rare cosmic surprises. A signal has reached us from the farthest edge of our solar system, demanding our attention. It all started with a subtle flicker, a barely noticeable shift in Neptune's distant glow. The James Webb Space Telescope, built to gaze into the universe's earliest moments, detected something no human could ever see firsthand. It witnessed a planet rocked by a violent, chaotic event, one that challenges everything we thought we knew. Our solar system isn't a quiet gallery. It's alive, unpredictable, and sometimes destructive. What unfolds next is the saga of a cosmic crash, a testament to human ingenuity, patience, and a discovery that will resonate for ages. Our journey takes us 4 billion kilometers away, to Neptune, the magnificent blue sentinel at the solar system's edge. There, a colossal wanderer from the outer reaches met its end in a spectacular world-shaping collision. This isn't a scene from a sci-fi movie. It's unfolding right now, and we're witnessing it firsthand. Though we are small, we've crafted instruments that let us peer across the cosmic gulf. We can observe as a giant planet is transformed forever by a cataclysmic event. This discovery is more than just numbers. It's a powerful reminder of the awe-inspiring force of the universe. The cosmos has sent us a message, and it's nothing short of breathtaking. To understand this discovery, meet the hero of our story, the James Webb Space Telescope, or JWST. Floating a million miles from Earth, JWST collects the oldest light in the universe, secrets from the first stars and galaxies. Built to capture faint, ancient whispers, it's one of humanity's greatest scientific achievements. JWST sees the universe in infrared, a type of light our eyes can't see but can feel as heat. Cold, distant worlds glow faintly in infrared, and dust clouds become transparent. Its giant gold-coated mirror gathers every possible photon, revealing what was once invisible. Before JWST, Hubble showed us the universe in visible and ultraviolet light. JWST is its successor, opening a new window on the cosmos. It's like gaining a new sense. Suddenly, we can hear as well as see. JWST is our sentinel in the dark, constantly watching and collecting data. Its position far from Earth gives it a crystal-clear view of the heavens. This sensitivity allowed it to spot the faint, telltale signs of trouble near Neptune. Without JWST, this colossal event would have gone unseen. Thanks to this golden eye in the sky, we were ready to witness the unthinkable and learn from it. Now, let's travel to Neptune, the 8th and farthest known planet from the Sun. Neptune is a true giant, 4 times wider than Earth, so distant that sunlight takes over 4 hours to reach it. It's a world of extreme cold, deep darkness, and swirling mystery. Neptune is an ice giant, a massive ball of gas, liquid, and ice with no solid surface. Its thick atmosphere of hydrogen, helium, and methane gives it a stunning blue color. But beneath this beauty lies violence. Neptune has the fastest winds in the solar system, whipping up giant storms. It's surrounded by faint rings and 14 known moons, including Triton, a captured object from the Kuiper Belt. Neptune's neighborhood is a frontier where the orderly solar system ends and chaos begins. For decades, our best views came from Voyager 2's flyby in 1989. Now, JWST's infrared vision pierces Neptune's haze, revealing weather, heat, and rings with clarity. During a routine checkup, scientists noticed something was off. Neptune's quiet patterns were about to be interrupted. The discovery began quietly, with a single puzzling piece of data. A team at the Space Telescope Science Institute was mapping Neptune's atmosphere using JWST. For weeks, the data was routine, until August 28, 2025. An automated alert flagged an unexpected change. Dr. Eris Thorne, a junior analyst, spotted a new point of light near Neptune. It was faint but real, and moving fast, aimed directly at Neptune. The team quickly realized the gravity of the situation. They requested emergency observation time on JWST, which was granted. The telescope was retasked to watch Neptune and the approaching object. The scientific community held its breath, about to witness a real-time, large-scale impact on another planet. JWST tracked the object's path with precision. The data revealed it was massive, perhaps 50 kilometers in diameter. Likely a rogue comet or small planetoid from the Kuiper Belt, it was on a collision course. Its long journey through darkness was ending in spectacular fashion. Final calculations confirmed, impact was imminent. The countdown began. For the first time, humanity would watch a planetary collision unfold in real time. The world's eyes turned to Neptune. The stage was set for a cosmic event. The moment of impact arrived on September 2, 2025. The object, now called the Visitor, was a dark, icy body, traveling for thousands of years. As it plunged into Neptune's gravity, it accelerated to incredible speed. The immense gravity stretched and tore at the Visitor, a process called tidal disruption. Then, it struck Neptune's northern hemisphere. There was no sound, only a brilliant flash of infrared energy that outshone the planet. JWST captured it all. The object and a huge portion of Neptune's atmosphere vaporized in an instant. Temperatures at the impact point soared to tens of thousands of degrees. A colossal explosion followed. A plume of superheated gas and vaporized rock erupted above the clouds. JWST's spectrographs analyzed the debris, detecting water, carbon monoxide, and silicates. The energy released was equivalent to millions of nuclear bombs. A visible shockwave rippled through Neptune's clouds. We were witnessing a world being wounded. In the days after the collision, JWST watched the aftermath unfold. A massive, dark vortex formed at the impact site, larger than Asia. This was no ordinary storm. It was a wound from the collision, visible for years to come. The impact changed Neptune's atmosphere, seeding new, bright ice clouds. The chemistry and temperature of the northern hemisphere shifted dramatically. By studying the scar and debris, scientists learned about Neptune's deep interior. The event also disturbed Neptune's faint rings, causing a wobble and brightening as new dust and ice were added. A new temporary ring could even form from the debris. We are seeing, in real time, the processes that shape planetary systems. This is a story about how all planets and their rings evolve. This discovery forces us to rethink our solar system. We once believed the era of big collisions was over. Now we know the outer solar system is still wild and unpredictable. Massive objects are still being thrown around, and major impacts can still happen. Planets are not isolated. They interact with their environment, and impacts can alter their atmospheres and structures. Neptune's event is a living laboratory for studying these processes. The size of the Visitor suggests there are more large bodies in the Kuiper Belt than we thought. The solar system is more dynamic and chaotic than we imagined. This event showcases the power of our new tools, like JWST, to witness cosmic events as they happen. We are no longer passive observers. We are active witnesses to the ongoing story of the cosmos. Our relationship with the universe has changed forever. Every discovery answers one question but creates a dozen new ones. The Neptune impact is no exception. The story has just begun. Scientists are racing to study the data, asking questions that will define planetary science for years. How long will the scar last? Will it fade or become something new? Where did the Visitor come from, and are there more like it? What are the long-term effects on Neptune's atmosphere and rings? This single, violent moment has set in motion a chain of events that will ripple for centuries. We are privileged to witness the beginning and to wonder what comes next.